Now, we're going to look over the course of this week. We'll be looking at how you can determine whether something has direct variation by looking at a graph, and how you can determine from a table whether there's direct variation, and how you can look at an equation. So today we're just going to talk about an equation because that's basically our definition of direct variation. Y equals kx is our definition, which means it could look like y equals 3x. That is a direct variation equation. All that means is your y values are going to be triple whatever your x value is every time, right? Like if I did what we call a t-table, and I plug in x values, like let's say x is 1. If x is 1, what would y be? 3, because y is 3 times whatever x is, right? So if y is 3 times 1, then y would be 3, right? What about if x is 2? Then I'd have y equals 3 times 2, so y would be 6. Right? What about if x is 3? Then I'd have y equals 3 times 3, which is 9. Okay? What about if x is negative 4? Then I'd have y equals 3 times negative 4, which is negative 12. Now, what direct variation means is every y value is just has the same relationship with every x value. This is just 3 times 1. This is 3 times 2. This is 3 times 3. This is 3 times negative 4, right? There's the same relationship between every single x and y value, and that relationship is multiplying by 3, right? Okay, so that's what direct variation means. Now, direct variation doesn't have to be a whole number. I could have another example of a direct variation equation would be y equals 1/2 x. If we filled out a t-table for this, let's say x is 1. Well, what's half of 1? Half, right? Yeah, or 0.5 to put it in decimal form. What about if x is 2? Well, then you have y is half of 2. So half of 2 is 1, right? What about if x is, let's do 4. What's half of 4? 2. Right? What about if x is 16? 8, right? Well, once again, I have a direct variation equation here because the relationship of this and this is half of that, right? This is half of that. This is half of that. This is half of that.
Just be making the table
So, no, you don't have to make the tables. What you need to see is whether or not it's direct variation. But what I'm showing you here is a direct variation equation looks like that right there, where y is equal to something. K can be any constant. Okay, constant just means it doesn't have a variable part, meaning it can be any whole number, any decimal number, any fraction number. Okay, I mean, as long as it's the same thing all the time, then that's fine. Okay, so all you're going to be doing tonight's homework, and I didn't give you many, just 8 problems, okay, is determining whether something's a direct variation equation. Now, if it's already written in that form, it's really easy. Is that direct variation? Yeah, it's y equals some constant, in this case 7 times x, right? So this one is direct variation. If I have, is that direct variation? Yeah, it is. Is 0.4 a constant? Does it change values, or is it always 0.4? Is it being multiplied by x?
Yes.
That one's direct variation. What about
Yes.
Yeah, is negative 3/4 the number? Is it being multiplied by x? Direct variation.
So it just
All right.
has to be a number.
Any number. What about,
No.
Yeah.
No, that's divided, so it's not
right, this one's not being multiplied by x, it's being divided by x. So this one is not an example of a direct variation equation. Now, those are the easy kinds. The ones that are a little bit, oh, actually, let me give you one more example.
You go to bed at night. Nope. Yes.
What about this one?
No. Yes.
No.
Yes.
Yep. Yes.
Yes.
No,
Yes.
because you're actually having another
Yes.
step. Which is
All
subtraction.
right.
No. Yes.
Does it look like y equals some constant times x?
Yes. Nope.
No, it looks like y equals some constant times x minus something. This is not direct variation. Okay, because direct variation, it's called that direct because there's a direct relationship. It's you do this one thing to x and you get y. And here we're doing not one thing to x, but two things. We're multiplying it and then also subtracting. So this is not direct variation. Okay, so if it already says y equals, it's really easy. If it doesn't say y equals some number, positive, negative, whole number, decimal fraction, it does not matter. Some number times x. If it doesn't say that, it's not direct variation. If it does say that, it is. Okay? Now, the ones that are a little bit more challenging are the ones that are not already in y equals form. Let's say I have this. And I ask you if this is direct variation. Nick, head up. Take notes. So, the first thing we need to do in order to determine if it's direct variation is we want to put it in y equals form. Now, all that means, remember when we were solving equations earlier in the year? You know, if I want to get y by itself, what do I need to get rid of? The x. And since I'm adding x, that means I need to subtract. You can subtract x. X is just a number. We don't happen to know what the number is right now, but it's just a number, so I can subtract it just like any other number. Because guess what? X minus x
It cancels out, and then you get
is 0. It doesn't matter what x is. If x is 3, what's 3 minus 3?
Zero.
What if x is 2? What's 2 minus 2? What if x is 123? What's 123 minus 123? So it really doesn't matter what x is. If I take x and I subtract x from it, it cancels out, right? So I get y equals 7 minus x. Is that direct variation? No, it's y equals something minus x instead of something times x, right? So that is not an example of direct variation. Okay? If I have this equation, what would I need to do to solve this for y?
Divide.
Okay, divide by 4.
And then do the same on the other side.
So I'd get y equals, and now this, you can just leave it as a fraction. You don't have to worry because 6 is not divisible by 4. So I'm just going to leave it 6 over 4. Is that direct variation?
No. Yes.
Yeah, it's 6/4 times x. So this one is direct variation. So if it's not already in direct variation form, all you have to do is take that step, look at what y is, and if you need to multiply something or divide something, inverse operations. If you're multiplying it by something, divide by that something. If you're adding something, subtract that something. Do whatever you need to do to undo whatever's with y to get y by itself, and then look at what's on the other side. And if what's on the other side, if what you have left is a number times x, then it's direct variation. If what you have left is a number minus x, or a number plus x, or x divided by a number, or something like that, or a number divided by x, something like that, then you know that it is not direct variation. So some of them will be more straightforward, like the first set. Some of them will be a little bit more complicated. Make sure that you show the work, which means if it's already in direct variation form, if it already says y equals something, just copy the problem down and put yes or no. If it's not already, then you need to show me what it would be when you solve for y.